Hi, it's Pavel. The purpose of this video is to provide some introduction to Golang language. What will be covered is a basic overview of its properties, some pros and some cons of using it in the project. I will also introduce a few of tools that made working with Golang even nicer. And by the end, I will show you some very simple examples of raw source code, while the far more advanced ones will be covered in the future videos in this series. What is Golang? It's a multi-paradigm, multi-platform, compiled and statically typed language, introduced in 2009. By design, is highly influenced by C language, but it provides us with a few quite nice features like memory safety. We don't really need to, unlike us while working with C, to worry about memory allocation. Golang handles it by itself, just as it provides us with a nice garbage collection system. It also introduced structural typing, which means that the types in row aren't determined as compatible by their names, but just by the internal structure like fields or methods. And one of the most important, I would say, aspects of Golang is its concurrency, which makes it great for distributed programming, for working with threads, with some background tasks, and so on. It also makes it highly scalable by nature. And Golang is claimed to be ultra easy to use just by design. It is designed to be easy to make us able to start working with it without any heavy training or so. It is similar to C by its syntax, so moving from that language would also be quite easy. What's quite nice about Golang, as for my opinion at least, is that it doesn't provide any virtual machine. It works strictly on operating system, which gives us faster compilation or execution. And the compilation itself provides a single executable file, so we don't have any bunches of files that we would need to link or find in file system while running our program. It's all in one place, which also makes it simpler. And such a compiled file is very light. So all the great features for making fast and small packages. It has some disadvantages also, of course. The ultra simple design, which seems to be great from the first sign, makes it quite hard to handle some of more complex processes that might seem to be basic in languages like Java, C#, and such. For example, creating some abstractions, abstraction layers might be a complex task for Go. It is multi-purpose, which also on the one hand might be great because we can use it for anything, but there is no single point of where Go would be better than any other language. So if we need to choose a technology for some specific use case, then most probably we would find something better. But if we want a language that would be a main point of our tech stack, it might be Go, as it could be used for any kind of work we would need to do. What's quite a heavy issue with Go is its error handling. If a function is meant to handle some error, it has to return it as one of return parameters. That is quite problematic, as the source code that full of if clauses, which negatively influences its reliability. The code looks just bad because of that, and trying to make it nicer is either hard or impossible because of that mechanism. Most probably you will see some of it in the future parts of this series. Considering compilers for Go, we can mention two main implementations. One is GC, which is self-hosting compiler toolchain from Google. It's optimized for Go itself, which makes it faster than GCC. It's way easier to use for cross-compiling of Golang, and the garbage collector is very precise for this one. If we don't want or can't use GC, there is Go Frontend, which provides us with let's say an abstraction layer over the GCC and LVVM compilers. I would say that for most cases, GC would be a better choice, as it's native for Golang. But we do have some options to work with popular ones as well. Also, there is a third-party Gopher.js, which allows to compile Go for front-end purposes to JavaScript. About a few of tools that would be used with improving our Go programming. There is Go FTM, which automatically formats our source code to defined format. It's great as we don't need to worry about formatting, which often takes quite a lot of time, or just mentions some errors if we run some check. Go does it automatically while using this tool. It's also basically included in Golang for sure, probably in some other of mainstream compilers IDEs as well. We have Golang, which allows us to execute scripts from command line, just like bash scripts. It only requires to put a Golang line on the top of the file, just as we would do with bash. And Goget, which makes a package importer. Its purpose is to download Git libraries and to save them in a Go path. We don't need to do it by hand. Thanks to that, it saves us some portion of work. Getting through some very simple examples. We have hello world written with Golang. What can we see here is the definition of package. Each file is in some package, which mostly relates to its location in the project. We have some import statement, where in this case we import a formatting library, which either formats data to strings or prints it on string. And in main function, we execute that basic print of hello world sentence to our string. Getting to a little bit more advanced example that shows the concurrency of Golang. We import both FTM and time library to work with time units. We have a definition of two basic functions here, which one reads word from command line parameters. It waits for us to enter a word in command line, and after pressing enter, it will save it to a variable. And we have timeout, which defines the time for us to put that word in command line. In this case, we sleep for 5 seconds and then return some value. And how this program works, we define chains for concurrent executions of timeout and read functions. So we made our program work for 5 seconds, and then we wait for user input. And depending on which will happen first, so if we manage to make it to 5 seconds to put a word, we will see that word printed on screen. And if we fail, we will see a timeout message. That's all that I have planned for this video. In the next ones in this series, I will show you some service microservice in Go using Gin REST server. That will include Dockerization, integration with PostgreSDB, and some more features that you will see in future. So thank you for your attention, and see you on the next videos.